there are lots of arguments that we need to allow everyone in the world to burn all the fossil fuels so they have a high standard of living, even though today fossil fuels are only cheaper because they are highly subsidized.
Fredi Otto, thank you for joining us on The Breakdown. How are you today?
I'm good, yeah, thank you.
Pretty good. So I'd love to just start with the basics. And it'd be great if you could tell us, what is attribution science? Walk me through a day in the life of an attribution study.
So attribution science is actually a bit broader than what I do, because there's on the one hand source attribution, so attributing emissions to emitters, so to companies or countries. So that's an important part of attribution. That's not what I'm doing. Then there is sort of further down in the chain of causality, then there is attributing emissions to global mean temperature. So that's been the first very foundational part of actually modern climate science. And that's where also the Nobel Prize has been given to, now I forgot his name, which is embarrassing. It will come back to me. Yeah. And then there is, of course, global mean temperature doesn't kill anyone, at least not directly. And so the part of attribution that I'm particularly working on is attributing extreme weather events to human-induced climate change. So that part of the causal chain, and then also going down to then actual losses and damages. So that, and what basically my work is answering the question whether and to what extent human-induced climate change has altered the likelihood and intensity of a particular extreme weather event. And we have done these studies now. So I founded an initiative together with a colleague who passed away a couple of years ago. That's called World Weather Attribution, and it's a global network of scientists who come together when extreme weather events happen that have particular impact on people, and do a study to answer the question, what's the role of climate change? So we've just published one that looked at the role of climate change in heavy rainfall in the Philippines. We've done one on the wildfires in Chile. They were the deadliest wildfires since the 2009 Australian wildfires that happened this year. So that's the kind of studies that we are doing. And so a day in the life of an attribution scientist is usually talking a lot to people in the area where the event occurred, trying to find out what kind of data is available, observational data, so weather station data, what kind of climate models can we use, and then talking to my team about, okay, when we then analyze that data, what does it look like?
Okay. And in very basic terms, for the non-experts among us, how would an attribution study work? How can you sort of isolate for the effect of climate change versus other factors?
Yeah, so the basic idea is actually really straightforward. So what we do is we find out, say, we are interested in this, the flooding in the Philippines that caused a lot of impact, a lot of death, and then we are interested in finding out what role did climate change play in the rainfall that led to the flooding. And so what we do is we first find out what has actually happened. So how much did it rain, where and when? Yeah. And so in that case, it was 5-day extreme rainfall in Mindanao Island, in the eastern part of Mindanao Island, at the end of January. Yeah. And then to do the attribution study, we find out, okay, what is possible rainfall over 5 days in that part of the world, in that season, in the world we live in today. So in a world that is already 1.2 degrees warmer than it used to be. And to do that, we use weather observations, statistical models, and climate models. And so get, all the possible heavy rainfall events that you could get in today's climate. And then, for example, find out that, okay, in today's climate, this is about a 1 in 10 year event. So on average, every 10 years, you have to expect such an event to occur. And then because we know very well how many greenhouse gases have been emitted and put into the atmosphere since the beginning of the Industrial Revolution, and how much warmer the Earth overall got, we can remove these greenhouse gases in the atmosphere of climate models and simulate possible weather in the world that might have been without climate change. And then look, okay, what are possible heavy rainfall events in Mindanao at the end of January in that world that might have been. And in this case, we found that without climate change, it would have been a much rarer event. So we would have only expected it to occur about once in 100 years. And because the only difference between these two worlds of possible weather is human-induced climate change, we can attribute the change, so the increase in likelihood, to climate change.
Okay, that makes a lot of sense. And I'm interested to know, I think a lot of the time what makes headlines, as someone who has followed your work, are the instances where there is a really clear relationship to climate change and the event that's happened. But what I found really interesting in reading your, I think, first book, Angry Weather, is that a lot of the time as well, what's really interesting are kind of these non-events, so events where it actually isn't climate change that's caused this, but that there's still a lot of, I guess, important information to be learned from that, and the kind of other factors that are at play. So could you talk a little bit about that?
So there are a few events where climate change does not play a role, or where the role of climate change is very small. So one of these events that happened last year was the flooding in the Emilia-Romagna in Italy. Where we found that overall, the likelihood of heavy rainfall that caused this flooding has not changed because of climate change, but a lot of other factors that human-made factors played a big role in the disaster, and the main one is urbanization and the sealing of surfaces in the area, so that when it rains heavily, the water has nowhere to go but in the houses and in the streets. That is something that we often see around the world. There were other events. For example, a couple of years ago, there was a drought that had huge humanitarian impacts in southern Madagascar, where also climate change did actually not change the likelihood of such a low rainfall year that had occurred, but a lot of other factors played a huge role. So, and on the one hand, it's that actually the way that the infrastructure in that area is governed. There's basically just one road, and then. Even though that sounds weird in a drought, but actually that road was flooded and so unpassable. And so no one could actually leave the area and go somewhere else to find alternative sources of income. So there was, and very, very high poverty rates. In general, the lack of any other source of income than agriculture led to this drought, leading pretty much immediately to famine and food insecurity for actually quite a long time. And climate change didn't play a role in that.
I think that's such an interesting point that also comes out in your book around the idea of what extreme weather actually is. So what constitutes extreme weather? And I found it so surprising there isn't really a sort of hard and fast definition, and that there's kind of an array of factors that play into it. So yeah, if you could expand a little bit on how that works. So it's not just weather systems, but also, I guess, sort of man-made issues and our various other impacts on a local environment, for example.
Yeah, so if you would ask a meteorologist what is an extreme weather event, the answer would be a rare event. And then you could just define it as an event that is a 1 in 100 year event, or more or rarer than a 1 in 10 year event, or there could be definitions based on that, and there are definitions based on that. But the way that we do our studies, we always work with the Red Cross Climate Center, and together with them, we have developed what we call our trigger criteria. Okay. So for flooding, for example, we consider doing a study if there are more than 100 deaths, or more than 1 million people affected, or more than 50% of the population affected. And for other types of hazards, we have similar humanitarian impact-based definitions. And based on these definitions, we have relatively frequently actually events that have huge humanitarian impact, but are actually not extreme from a meteorological point of view, but are events that, at least in today's climate, happen, well, on average every 5 years or even more frequent than that. But because the vulnerability is extremely high, and maybe also because other events that have happened in the area that have reduced the coping capacity of the population, these events can still have really big impacts.
Right. I want to come back to vulnerabilities later, but I just kind of want to step back a little bit and ask what might sound like a fairly basic question. But speaking to your point at the very beginning about the fact that, you know, global average surface temperature isn't what kills people. And I think that's so often how we talk about climate change, which is something I find frustrating because, you know, 1.5 degrees doesn't really mean anything to anyone in tangible terms. And I think we also have this idea of climate change as this kind of universal experience across the globe, this kind of everywhere will get hotter, drier, more hostile in the same kind of way. But the reality is far more complex. So without wanting to go too far down a wormhole, could you talk a little bit about how climate change, so sort of warming planet, actually creates such varied impacts kind of all around the world? Kind of what physically is happening in our atmosphere that makes it such a kind of petulant or kind of diverse experience when it comes to actual impacts?
So on the one hand, we have, of course, the physical impacts, which are comparably evenly distributed. So it is that the poles warm faster than the equator, but actually in terms of the distance from the norm, or the distance from the weather we have been used to, the changes are larger in the tropics. While if you look at the absolute temperature increase, we have sort of 1 degree increase on the tropics, but something like 4 degrees in the Arctic. Right. But when you look at how many more extreme events you get, these are much higher in the tropics compared to the polar regions, and that's of course what leads to the impacts, because our societies are every ecosystem, every society, everything is built around the possible weather that we have experienced over the last hundreds of years of a very stable climate. And if you shift that, that's what's causing the problems that we have. And because the shift is larger in the tropical regions, which is of course also where a lot of the most vulnerable populations live. So that's just from the physics why the impacts there are stronger, because they're even small. What looks like small changes are actually big changes in terms of what we are used to and what societies have been built to on. But then, of course, in those areas, you have in many cases all the colonial history that has led to arbitrary drawn boundaries of states, and therefore conflicts and unclear responsibilities, and also just a lack of capacity to deal with these, which means that even if the weather event is the same, the changes the impacts are much, much stronger. So a striking example is Storm Daniel. That was a storm that hit the Mediterranean in September 2023, and it hit Greece as well as Libya. And in Greece, you had large-scale flooding, infrastructure damages, and also a few fatalities. But in Libya, it led to thousands of deaths, and that was because the storm came overnight and hit a city that was actually, in theory, protected by a dam, but that dam has not been maintained for the last 20 years because Libya has been preoccupied with civil war, and there was just no governance. And so that dam did not withstand the flooding, and also there was no early warning. So it came as a complete surprise, whereas in Greece, the weather forecasts have, and there was, and the governance has warned the population, and that of course saves a huge amount of lives.
So on that point about sort of damages and the kind of differential experience of climate impacts, one of the biggest, I guess, or at least most public kind of applications of your work seems to be its role or its potential in the court system and potentially holding parties accountable for their role in the climate crisis, whether that's major corporations or governments themselves. So could you talk a little bit about, in sort of concrete terms, how that would work, how you can use an attribution study to look at accountability, and if there are any interesting examples or sort of positive cases where this has been successful or looks like it might be?
So as I said earlier, the kind of research that I'm doing, the studies that we are doing, is sort of one important part of the causal chain from emissions from individual countries or companies to greenhouse gas concentrations in the atmosphere, global mean temperature, and then changing extreme weather events and their damages. And so that last bit was for a relatively long time a missing bit in this causal chain, and that we have, at least in some cases, have filled that. And that's why it's important, because it can causally prove that emissions of most studies that we do are just overall, all emissions, all climate change. But we can do these studies also for emissions of just one country or just one company, and then you can see how the emissions of a company or a country have increased the likelihood of an extreme heat wave to occur. And therefore then, of course, also heat waves are by far the deadliest extreme events that there are globally. And so also then you can attribute the additional death because of this additional increase in extreme heat. And that is an important part of the evidence of these claims where people sue countries or companies for damages. So there have been, climate litigation has been on the rise very much in recent years, and one reason for that is just the complete inadequacy of the political response. But another reason is also that the evidence of the impacts of climate change is much stronger now. And there have been many successful cases, and they are all so far with respect to forcing governments and companies to do more on the mitigation, so to do more to avoid future damages. And there was one study, for example, from an NGO called Bushfire Survivors against the EPA in Australia, where the survivors of the bushfires in 2020 have sued the EPA that they haven't done enough to mitigate climate change, and that used actually our study on the role of climate change in these bushfires as part of the evidence to show that it's actually, climate change is actually extremely dangerous for Australian people here and now. It's not a future problem. It's not a problem for someone else. And these kind of cases have been, so there are cases like that in the Netherlands, in Germany, but there are also now a lot of cases, and most of them are still ongoing, where companies or countries are sued for actual losses. So there is one on the European Court of Human Rights at the moment pending, where they call themselves the Klimaseniorinnen, so it's older ladies from Switzerland are suing the government for not protecting and for leading to more death for especially them, because the elderly are those who predominantly die in heat waves. So that's still ongoing. There is the county of Multnomah, Oregon, has sued the 12 major US-based fossil fuel companies in Oregon with respect to the damages they caused in the heat wave in 2021. That's also still ongoing. There's one case that's already relatively far in the judicial system. That's where a Peruvian farmer has sued RWE in Germany for the potential damages they will cause because of the glacier melting that had led to a glacier lake increasing massively in size, and that's a huge threat for the city of Juarez, where this farmer lives, and that case is also still pending. But that has been a really interesting case because it has been dismissed in the first instance, but then on appeal, the judges have said, no, this is a really important case, but we don't know enough. We need to educate ourselves. And so the judges have actually gone to Peru and spent a huge amount of time reading the science with scientists to understand what it is they are advocating. So pretty much independent of their final decision, it's a really important case because it showed that this is now something that courts should deal with.
What do you make of the argument that people make about that kind of now, I think, well-known figure about 100 companies being responsible for about 70% of emissions? And so often the counter-argument is that, oh, well, those emissions are associated with, all of us kind of consuming fossil fuels through energy, through the cars we drive, etc. And so you can't attribute responsibility in that way. What do you make of that argument?
Well, I think that argument is very flawed because, of course, we consumers are the ones who ultimately burn the carbon, but those companies, they sell that carbon, they sell the fossil fuels, knowing full well that the only thing that you can do with it is burn it. And also, they have had that knowledge for a long time. So since the 1960s, actually at that time, especially the US companies had very good scientists who told them very clearly what you're doing is not sustainable. It will lead to massive damages. And instead of changing their business model and changing what there are companies that used to be fossil fuel companies that have changed to completely just be renewable companies. So it would be an option that all fossil fuel companies would have had, but they decided not to take that route, but instead to saw disinformation, and we are all still suffering from the massive disinformation campaigns that these fossil fuel companies have run. And therefore, there is at the moment, as a consumer, you have very little option actually to do something different. Because if you're very well educated and well informed and relatively rich, you can make sure that your electricity comes from renewable sources, and you can buy an electric car, and you can buy houses or rent houses in the city centers so that you can use public transport. But the vast majority of us can't do that because you need resources, you need information and money to live a fossil-free lifestyle. So you cannot blame the population for using what policy and industry have had the responsibility to change, but have decided not to do it.
And have profited handsomely from.
Oh yes, of course,
record profits. It's interesting, actually, the point around disinformation. I think I'd be really interested to hear from your perspective as someone kind of on the ground doing climate science, in the hot seat, kind of defending the science. It seems like, kind of overt climate denialism is sort of on the wane, although it continues to rear its ugly head sometimes. But that the nature of kind of disinformation and sowing doubt about particular elements of the science or how it can be linked, for example, to particular companies or responsibility, that continues to evolve. So where do you think we are in terms of, I guess, disinformation and the kind of fight to communicate climate science clearly and sort of bring everyone on side?
So I think the biggest misinformation or the biggest gap in information is this often implicit narrative that burning fossil fuels is causally linked to a high standard of living. And of course, historically, that was the case because the fossil fuels were cheap and therefore were a source of cheap energy, which actually, to start with, also just benefited the very rich. But then with the inclusion of social security systems and so on, helped countries to have a much higher standard of living overall. But it is the fact that it was cheap energy. It's not the fossil bit that actually is important, but that is something that will often be left out. So there are lots of arguments that but we need to allow everyone in the world to burn all the fossil fuels so they have a high standard of living, even though today fossil fuels are only cheaper because they are highly subsidized, and of course, let alone all the damages they cause. So I think that narrative is not that this false causality that fossil fuels equal high standard of living, that's not caught out, and that people buy that easily. That's, I think, one of the big problems. And then I think we also have a problem with, I would say, the image, if you like, of the world we would like to live in, because it's still a fossil fuel. So freedom, driving in your convertible across Route 66 is sort of the epitome of freedom, the image that everyone that has sort of had some contact with Western culture can somehow relate to, and that's and we don't have anything like that for a fossil-free world. We have sort of relatively clinical and theoretical ideas of the 15-minute city, but it's not. We don't have stories. We don't have movies. We don't have books. We don't have heroes. We have nothing that makes that cool. And I think that's a big problem. That is more of a problem than, I think, nowadays, than people actually disputing the science. I mean, that still, as you said, they still sometimes pop up, and there is still a big problem, I think, from a science point of view, is that a lot of journalists also, when they report about findings from climate science, just highlight all the uncertainties, and scientists, when they talk about their work, highlight all the uncertainties, but don't say what we actually do know and where we are actually certain, and that the uncertainties in climate science are, well, just science. You have uncertainties in all science, but in climate science, they seem somehow an insurmountable problem to do anything ever. Whereas in all other parts of science, of course, we deal with uncertainty, and we can sort of estimate with what sort of the size of the uncertainty is, and then make decisions on it. But in climate science, uncertainty is always used as an excuse not to do anything, and I think that's a big problem, and that's also a problem on how scientists talk about their work, because we have been so drilled in highlighting the uncertainty that most of us really can't talk about anything else.
Right. And what does uncertainty in a scientific study actually mean? I know that sounds probably like a very basic question, but it sort of has a technical definition that I think is important and that is often misunderstood, because it sounds, to someone unfamiliar, like you just don't know what the results are.
I know. It's really every measurement you make, every model run you make has sort of what we call an uncertainty range. And that's a really bad misnomer, because it should be called the certainty range. Because when you measure something, you always have your instruments of measurement are usually not perfect, or the conditions in which you do the measurements are not perfect, so you will not get out a single number. But when you repeat the same measurement several times, you will get a few numbers. And if your uncertainty range, or rather your certainty range, is low, if you have something that's relatively easy to measure, you have good instruments, then that might change between it, it's always within the same order of magnitude, and this uncertainty range is pretty small, but it's still there. So even with the best measurements, and then of course with things where we don't have perfect observations of the weather in the world. We have very good observations for British weather, but we have very poor observations for the weather in the Congo Basin. And so depending on where you do a study, this range of within which the results fall, if you repeat the study, and we always repeat, we always do the same experiment many times. We always use different models. We always run the same model several times, and then we use very different models precisely because we don't have perfect models to estimate how large this range of possible answers is. And that means we will always only have, as in every other science, because that's really not something that's special to climate science. That's the same in all other fields of physics. I think people might still remember from COVID that there were huge uncertainties of whether an effect was even small or big, and that is just how science works. And the way to deal with that is to use many different ways to try and answer the same question. And if all the ways come up with a very similar answer, then you have a very high certainty. And how climate change affects global mean temperature is something which we actually now know with almost 100% certainty. How climate change affects heat waves is in sort of a qualitative way. We also know that with absolute certainty. But in a quantitative way, if this heat wave was made 10 times or 30 times more likely, that's often something that is hard to determine. But of course, that doesn't mean we don't know anything. It just means we can't quantify it exactly, but we can only give a range.
And within that range that it's definitely made more likely. It's just by how much.
Yes, exactly. And we know it's definitely made more likely than 9 times, but whether it's 10 or 30 times, it's somewhere between.
Yeah, it's so interesting that you brought up the COVID example, because for my sins, I actually listened to a lot of fairly right-wing radio to try and learn what everyone's up to. And that comparison between the kind of what had to be necessarily very quickly done modeling of sort of the curve in COVID and sort of errors or any uncertainties there was actually drawn so regularly as a parallel to climate science as a way to try to undermine it, which I found so interesting. I want to touch base a little bit on your newest book, which I won't try to butcher the name because it's got one of those brilliant German titles that feels like a very long combination of words.
The translation is just climate injustice.
Climate injustice. And the book links explicitly, I guess, the work that you do on climate science to capitalism and to injustice and inequality across lots of kind of categories, whether that's sort of racialized inequalities or gendered inequalities. And I think it's really interesting because those links, particularly the link between capitalism and climate change, feels like something that's made quite commonly by sort of activists or in the kind of political economy space. But it's not something I see as commonly from the kind of science community. And I'd be interested to know both maybe why you think that is, and then also as a scientist, how you see that link between sort of climate change and capitalism.
Yeah, so I think why it is just because it's so obviously political, and the climate community is still trying to defend the idea that climate science is not political, which I think is just not true. Climate change is causing a few winners and lots of losers, and that is inherently political. So you can't research climate change without it having political dimensions. But I think that's a reason why a lot of scientists don't talk about this and just talk about sort of the more physical side of things. Sure. So that was your first question. What was your second question?
Okay. How you see the link between.
So, and I think I'm not 100% happy with the subtitle, to be fair, because capitalism, this sounds as if because it often is if you criticize capitalism, it's often taken as you criticize us fundamentally, and you're a communist, and you want to. And I think I don't think that capitalism, sort of with the basic ideas about capitalism, that you have private ownership and that you have markets, I don't think that is per se a problem. But the way we have implemented the capitalism in the world today is ultimately what causes the problem of climate change, because it measures everything in GDP, so in highly aggregated numbers, and not of who actually benefits from this. So, and just because people will then put in the comments, I'm degrowth, I'm not degrowth. I think growth is actually really important, but it totally matters what growth and who profits from that. And that, I think, is, at the moment, it's just growth per se is what the capitalist system we live in is geared towards growth per se, and it doesn't really matter who profits from that, and who pays the price. And because we have this system, that's exactly why we don't do anything about climate change, because you still can make a huge amount of money with selling oil and gas and coal. There was at the very beginning of the Industrial Revolution, it was that there were few who profited and a lot who paid the price just in the mines with their lives and livelihoods, and then with the colonial system that got sort of shipped across and was less domestic, but it was still the same system that you have a few profiting and a large part of the population paying. And as long as we don't take this, I think as long as we don't take this fundamental idea of this is how capitalism should work, and we will not be able to solve the problem of climate change, because it always those who are who have fewer money, who have lower education, who are the ones who pay the price. And it will never be that those of us who are rich and well educated, we are not paying the price for climate change, because we can afford to live in well insulated homes, so heat waves are less of a problem. We can afford to not live in floodplains, so floods are not a problem. And that's therefore this implementation of capitalism in today's world is, I think, the fundamental problem that we have with climate change.
So do you see a kind of possible future in which capitalism and a kind of more sustainable economic model, but also one that is more just, is possible? And if so, what does that look like to you? Sort of what are the kind of dynamics that need to be overcome? So whether that's, is it just undermining the profitability of fossil fuels, or is it, ensuring that fossil capital doesn't have so much political influence? What are the kind of levers that you think need to change in order to sort of reconcile capitalism with a more just,
I think those
world?
two are definitely important. So that the fossil industry has so much political influence is a huge problem. And then I think for me, what is completely missing in all these discussions are human rights. So the Paris Agreement in the preamble says very clearly it's a human rights agreement. We care about climate change because we don't just have capitalism. We also have the human rights that are for everyone: the right to life, the right to health, and climate change fundamentally violates the human rights of a vast part of the global population. And I think it's 75 years ago now that the Declaration of Human Rights for everyone has been made, and it was for a reason, and the reason was not charity. It was because it was in the aftermath of the Second World War, where which completely destroyed Europe, and by recognizing the human rights globally, that has actually played a big part in rebuilding Europe, because in Europe that has then actually been something that has been taken into account when implementing, and that has led to the influence of the rise of social democracy and social security systems. And I think we could do this globally. There is no reason why this shouldn't be possible globally. And of course, since then, a lot has happened, and it was also not equitable and as just as it should have been and could have been at the time. But there is nothing inherent in using markets in having human rights that would prohibit to do this for the whole world. But I think that's sort of the most important things, that to realize that human rights are for everyone.
So just to wrap up, I'm interested to know where you see attribution science, or at least your sort of subsection of that causal chain, going next. What do you think is sort of potential that it has that is still unrealized in kind of changing the fight against climate change?
So I think it's still this. We are still the only team in the world who do these studies rapidly. So who do these studies in the immediate aftermath of the event occur. There are a few other people across the world who do that on a scientific basis, who write scientific papers, but they are usually published 2 years or so after the event occurred, when the public discourse has moved on. And I think it is still really important to bring this, which was the reason why we founded World Weather Attribution, is that the question of what's the role of climate change has been asked. But before we existed, the only people who were given answers were those who only had political opinions, but no evidence. And so what we do is provide the evidence in this discourse. And I think that is still really important, because with that, we bring the relatively abstract science of climate change and climate science together with the experience of people. And that helps us and everyone to understand what climate change actually means. And I think that is really important, because for a long time we didn't really know that. We knew there will be more heat waves and more floods, but what that actually means and who is affected and how that plays out, we didn't. And we know that now, and that's what the science that we do show. But we haven't done it globally yet. So we have done, and we are, with my team, we are trying to prioritize regions of the world where there is much less science and much fewer studies, but there's still some way to go. So I think there's just still a role for this. And I hope that eventually Met Services will take over this role. And then I think the other important thing is to really bring together the physical changes in the hazard because of climate change with what happens in terms of changes of vulnerability and exposure. Because in a lot of cases, so the Philippine example that I talked about at the beginning, a lot of the damages that there were so many landslides is because of large-scale deforestation in the area, and I think just having all this information with the same scientific framework is really important to then feed that in to political discussions on loss and damage, on adaptation, because at the moment the physical science and the more social science on vulnerability are still completely separated, don't speak the same language, are not available on the same scales. And I think that bringing this together is important to make progress on increasing resilience, on adaptation, and on loss and damage.
Fredi, thank you so much for joining us in this conversation.
Thank you for having me.